Hey folks, welcome back to another video. Today we're looking at question 1038, binary search tree to greater sum tree. The way we'll be solving this problem is by using recursive search. And like a recursive method where we keep recursing till we find like the rightmost node, which will basically have like the greatest value. So if you see in this example, the greatest value here is 8. So we keep going all the way down and we keep track of the sum of the greatest value that we see, and we keep moving up. So let's get started. The first thing you need is a variable sum, and the reason why we're declaring it as a global variable is because like we'll be calling this method recursively, so that since we're calling this method recursively, we want to make sure that the number is not necessarily overwritten. That's the reason why we have a global sum. All right, so what do we do here? So since we have to get to the rightmost node, if root dot right is not equal to null, you would call this again on root dot right, and this will keep getting called till you get to the rightmost node. And then once you get that, the sum would be the value of the current node dot root dot value, and the value of that node is overwritten by the sum. So in this case, if you reach all the way till 8, it's initialized to 0 and you only add 8, so that will be reassigned. But as you go up, it'll keep a track of all of the numbers that you've seen previously by adding all of them in the sum. And then once you've added that, you want to make sure you go to the left, and then you basically call it the same. So if tree root dot left is not equal to null, you'll recursively call it on this. Will be root dot left, and in the end you need to return the tree node, and that case will be return root. So I think that's all we need. Let's try running this. The first few test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity of the entire solution. The time complexity of the entire solution is of n, since we have to recurse through all of the nodes in the tree that's given to us. The space complexity of the entire solution is of n, since we would be using, like we're calling this method recursively, and those calls are stored in a stack, so that would be of n. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I'd really appreciate that. It keeps me motivated to make more videos. Thanks so much, and I'll see you folks soon. Peace.